You've probably heard the term AWS thrown around and just, nodded along, figuring it's some super complex tech thing. Well, today, we're going to pull back the curtain and make it simple. I want you to think of Amazon Web Services not as some scary, intimidating cloud, but as the world's biggest box of digital Lego bricks. Seriously, by the end of this, you'll see exactly how these blocks are used to build pretty much everything, from Netflix to your favorite new app. All right, you ready? Let's jump in.
So, here's our game plan. First, we'll take a quick trip back in time to see the problem that really started this whole cloud revolution. Then, we'll explore the mind-boggling global scale of AWS. After that, the fun part. We'll get our hands on the core Lego bricks, see how they snap together to build a real website, and then wrap it all up with why this stuff really matters for the future.
Okay, so let's start with the why. To really get why the cloud is such a big deal, you have to understand what it was like before. If you wanted to launch a website or an app, you had to dive into the messy, super expensive world of physical hardware. And this slide, this right here, just nails the difference. On the left, you've got the old way, on-premises. That meant buying a giant pile of expensive servers, trying to guess how many you'd need, which, spoiler, you'd always guess wrong. And then you were stuck paying to maintain them 24/7. It was slow, risky, and a total headache. But on the right, you've got cloud computing. Instead of buying, you just rent. Need more power for a Black Friday sale? You get it in seconds. Things quiet down, you scale back and stop paying. It's elastic, it's on demand, and the best part? The provider, AWS in this case, handles all the annoying maintenance for you.
So, the really crucial thing to understand is this wasn't just a tech upgrade. Nope. This was a fundamental shift in how businesses operate. Companies went from making these massive, risky, upfront investments, that's what we call capital expenditure, or CapEx, to a super flexible pay-as-you-go model, that's operational expenditure, or OpEx. This change unlocked an incredible amount of speed and innovation, because it meant anyone with a great idea could start experimenting without needing $1 million in the bank just to buy servers.
All right, so now we know why the cloud exists. Let's talk about the sheer scale of it all. AWS isn't just one giant computer in a basement somewhere. Oh no, it is a massive, interconnected global network that powers a huge chunk of the internet. AWS organizes its whole world like this. First, you have these things called regions. Just think of them as big geographical areas, like the US, Europe, or Africa. But here's the really clever part. Inside each region, there are multiple, totally isolated availability zones, or AZs. The best way to picture an AZ is like a separate building in a big office park. Each building has its own power, its own cooling, its own network. So by running your app across multiple buildings, if one has a blackout, who cares? Your business just keeps running from the others without skipping a beat. This right here is the secret sauce to making things highly available and fault-tolerant. Okay, now for the really fun stuff. Let's finally open up that Lego box and check out the most important bricks, the ones you can use to build pretty much anything you can imagine online. And we're going to start with the most fundamental service of them all. Compute. EC2 is the absolute workhorse of AWS. Honestly, the easiest way to think about it is you're just renting a virtual computer. That's it. You can pick its size, how much brain power, how much memory it has, and you can launch it in minutes, anywhere in the world. It is the digital version of having a physical server, but you never, ever have to touch a single cable. But what if you don't even need a whole computer running all the time? What if you just need to run a tiny bit of code for a split second? Well, that's exactly what AWS Lambda is for. You're going to hear this buzzword serverless a lot, and this is what it's all about. You don't think about servers at all. You just upload your code and tell AWS when to run it. So you could say, hey, Lambda, every time someone uploads a new photo, run this little piece of code to create a thumbnail, and you only pay for the fraction of a second that your code is actually running. It's efficiency on a whole other level.
Of course, every application needs a place to store stuff, and for that, AWS gives us S3. The best analogy for S3 is a bottomless digital filing cabinet. You can throw anything in there, images, videos, backups, your entire website. It's incredibly cheap, it's secure, and it's built for a scale that's just hard to wrap your head around. And when I say it's durable,
I mean this number. Look at that. That is 11 nines of durability. It's kind of a ridiculous number, right? So let me put it in perspective for you. If you were to store 10 million files in S3, you could expect to lose just one of them, maybe every 10,000 years. It is an absurdly, unbelievably reliable place to keep your data safe. Next up, we've got databases.
most apps need a really structured way to store things like user info, product catalogs, or order history. That's where RDS, the Relational Database Service, comes in. Now, the key word here is managed. AWS handles all the painful, boring parts of running a database, things like patching, backups, and scaling. This lets developers just focus on building cool features for their app instead of being full-time database janitors.
And finally, how do you keep all these different services safe and organized? Well, that's the job of the VPC. A virtual private cloud is exactly what it sounds like. It's your very own private, fenced-off little neighborhood inside the massive world of AWS. You control the whole network, who can get in, who can get out, and how all your little Lego bricks talk to each other. It's really the foundation for all your security.
So, we've seen the individual bricks, right? We've got compute, storage, databases, and networking. Now, let's see how they all snap together to build something we all use every single day, a fully functioning, scalable e-commerce website.
Let's just follow a single click. So a user comes to your website. The very first thing their request hits is a load balancer. Think of it like a traffic cop for your website, making sure no single server gets too busy. That traffic cop then sends the request to one of our EC2 virtual servers. That server then zips over to the RDS database to grab product details, like the price and description. At the exact same time, the cool product images are being loaded super fast from our S3 storage bucket. And watching over this whole orchestra is a service called CloudWatch, which is kind of like a security guard, constantly checking the health of every single piece. You see how each Lego brick has its own specific job? That's the real power of building on AWS.
So, we've gone from the why to the what and the how, but let's just zoom out one last time and talk about the big picture. Why is any of this actually important for you to know?
The big takeaway here is that cloud platforms like AWS have completely changed the rules of the game. They allow anyone, from a tiny two-person startup to a giant corporation, to innovate at a speed that used to be impossible. It gives any business instant global reach. It's creating entire new career paths like cloud architecture. But most importantly, it lets us stop worrying about the plumbing, the servers and the cables, and lets us focus on what actually matters, building amazing products and creating real value in the world. So I'll just leave you with this one final thought. Now that you know what these building blocks are, try to think of AWS as this unlimited creative toolkit. It's not just about technology, it's about pure possibility. So ask yourself, if you could build absolutely anything without having to worry about servers or scale or any of that, what's the first problem you would solve?